Hello and welcome to my channel, and in this video we detect color of an image using OpenCV and Python. So we start by importing a few important libraries. We import OpenCV2, which is called as CV2. The package is called as CV2. We import NumPy Python library, and we import the Matplotlib library in order to display the image. So we start first by loading the image in a variable image img, and we do that by using the OpenCV2 function imread, and I mentioned the location of the image, that is it is stored in this particular location. I'll show you that. So this is the particular image that we will be using in order to detect the color. So let us now run that part of code. I'll run this part of code, and okay, I did not run this part. I run this part of code, and once again I'll run this part of code, and it successfully loaded the image in the variable. Now I'll display that particular image using the matplotlib function, and okay, this is the output that I get, but this does not look like yellow, this does not look like orange, this does not look like red, and this does not look like a dark blue color. So this is because OpenCV by default loads the image in the color format BGR and not in the RGB format. So we need to convert the color format from BGR to RGB format. So we can use the convert color function of OpenCV2, and I'll just write the code and you will be able to understand. So I'll name it as grid RGB as a variable, and I'll use the cv2 dot cvt cvt dot cvt dot convert color function, and I want to convert this particular image, and I want to convert it from, I use the cv2 dot colo color, and I want to convert it from BGR to RGB. So this particular line of code will convert that image from BGR format to RGB format, so that we'll be better able to see that image. So I'll just copy this part and I'll paste it here, and then I'll just grid RGB. Now I'll run this part of code, and as you can see here, this is proper yellow, this is proper orange, this is proper dark blue, because we converted the image from BGR format to RGB format. What we will do next is, OpenCV, in order to detect the image, uses HSV color format instead of BGR or RGB. So now we need to convert this particular image from RGB format to HSV format. So I'll just copy that part of code and I'll just rename it from RGB to HSV in order to match everything, and this image I will replace it by grid RGB. That is the image we converted from BGR to RGB. So I'll run this part of code but before that I want to convert it from RGB to HSV. It will convert this particular image from RGB format to HSV format. So I'll run this part of code and it successfully ran it. Now in order to detect the color, we need to mention the HSV range of the color that we would like to detect. So I will have to mention the lower HSV color range and the upper HSV color range in order to detect the color. So I will mention the lower color range as HSV values as lower as np dot, it will be an numpy array, and here I will mention the HSV values. So let's, for example, first I want to detect the yellow color. So I will mention the HSV value, lower HSV value for yellow color. the H value, lower H value is 25, the S value is 1, let's take it as 150, and the upper value is 50. And similarly I'll have to mention the upper HSV value, so I will just change the variable name as upper, and the upper value will be 35, and instead of 150 I will change it to 255, and here as well I will change it to 255. So the first item in this particular numpy array, the first item is U, the second item is saturation, and the fifth item is value. U is basically the color, so here the U is yellow, here the U is orange, here the U is blue, and saturation means how strong that particular color is, and the third item, that is value, means how bright that particular color is. So these were the lower HSV values of the color that we want, and these are the upper HSV values of the color that we want to predict, and these are the HSV values for yellow color. Now I'll run this part of code, and next I will use the OpenCV to in-range function in order to only show us the selected color and blacken out the rest of the colors. So I will name the variable as mask equals cv2 dot in range, and I will mention the image, that is grid HSV. I'll copy it in order to avoid spelling mistakes and paste it here, and I will mention the lower HSV values and the upper HSV values of the color that we want to detect. So I will run this part of code. Next, what I will do is I will just display this mask that we created here. I'll copy this plotting function and I'll paste it here, and instead of grid RGB I will write it as mask, and I'll run this part of code. And as you can see here, it properly detected the yellow color, but this actually is not a yellow color, this is just a mask. So in order to see the actual yellow color, we need to remove this mask and see the original image. So I will write another bitwise AND operator function of OpenCV, which will do that for us. It will remove the mask and it will show only that particular color and blacken out rest of the colors. So I will name it as res, for example, and I will use cv2 dot bitwise underscore AND operator AND function, and I will do the bitwise AND operation between this grid RGB variable or grid RGB image. So I'll paste it here, and I will mention the mask. Mask is equals to mask because I have named the variable as mask. Now I will run this part of code, and once again I will copy this plotting function and paste it here once again, and this time I will name it as res. So as you can see here, it was able to properly detect the yellow color, and it masked it, or it blackened out rest of the other colors. So here we detected the yellow color, but now let us make some changes and let us just detect a few more other colors. For example, let us detect the red color. Let's take an example of the red color now. So what I'll have to do is I'll have to change the HSV lower and the upper values. So for red color, the lower value is 0 and the upper value is 10 for the U, and the rest of the values will remain as it is. So I'll run this part of code once again, and this one as well, this one as well. So as you can see, it created a mask right on top of the red color, and the bitwise AND operator will actually show us the proper red color in this image. So as you can see, it removed the mask and shows us the original color. Now let us detect another color For example, let's see the dark blue color. So I will change the HSV upper and lower ranges. So for dark blue, the lower range is 115 and the upper range is 125. The rest other values will remain the same. I run this part of code, run this once again, and as you can see here, it created a mask on top of the dark blue color. So I'll run bitwise operator, and as you can see, it is able to show us the dark blue color that we detected using the HSV values of the color. So this was a basic example where I used a custom image which consisted of various colors. But now let us take a different example. I will show you one image and we will detect color from that particular image. So we will try to predict some or detect some colors from this image. So the name of the image is mountain. So I will just make small changes. So instead of colors, I will rename it with mountains because that is the image now that we are trying to predict, and we will try to detect the green grass. I will try to detect the green grass of this particular image. This is the green grass, so I will have to mention the HSV values in the range of this particular green color. I will clear the output and I will start it from scratch once again, but with a different image this time. So I import the libraries and I load the image. Now I see how the image actually looks like, but there is a small error. Sorry, I made a small mistake here. It doesn't mean mountains, it is just mountain. I run this part of code once again this one, and as you can see, this is the image, but it is in BGR format. So next we convert it to RGB format, and I'll plot this once again, and as you can see, this is the original image as it looks, as I showed you previously. Now I will convert it to HSV format, and now I mentioned the lower and upper range, but I want to detect the green grass. So I mentioned the lower and upper range for this green grass. With the green color, the lower and upper range is 35 and the upper range is 75 for the green color. So I run this part of code. I made the changes for the lower and upper range. Now I create a mask here. I plot the mask, and as you can see, this is the mask for the green color that I mentioned in the range. And now I run this part of code. I use the bitwise AND operator, and now I display the image. As you can see, it properly detected the green color and it displayed it in front of us. So this is how we detected the green color, but let's detect another color, this particular red color, that this guy is me. So this is the red color bag that we would like to detect. So I will, as we saw previously, that the lower and upper range for red color was 0 and 10. So I will run this part of code once again, the same one, and as you can see, it created a small mask where this guy where I am carrying this red bag, and I will run this part of code once again, and as you can see here, it detected a red color from this image. I will try to zoom in. This is the red color bag that we were able to detect. So this was a basic tutorial where we detect color from images using OpenCV. So I hope you liked the video. Please click on the like button and subscribe to my channel. Thanks a lot for watching.